Hello and welcome back to my channel and to the series which is titled as ConQuiz, and as you know that it has a subtitle that Concept Booster series, though basically the aim is to help you to prepare for different exams including your basic chemistry honors, IIT-JAM, NET, GATE, etc. So as you know that in the first 3 episodes of this series we have conducted some session on general preliminary chemistry, and then on quiz 4 to 8 we have covered chemical kinetics, and followed by a very interesting episode which was on thermodynamics, but I called it ConQuiz bonus. And then ConQuiz-9, that means today's session onwards, a few episodes would be there on thermodynamics, concept booster on thermodynamics, right? So as usual we'll start with part 1 with rapid fire question and answers. The answers are true false kind of questions. Today's on first law, there would be a second part on second law. So how I will deliver today's session is something like this, that I will first give you the questions. Every slide will contain a couple of questions, and a total of 28 questions are there. So after listening to the questions, you just give pause to the video and think over the problems, think on the probable answers, and mind your solution logic for your answer, and then you can check and compare, of course, your answers and solutions to that of mine in the second half of the session, right? So I would like to start with the questions. First question, another point is that it is easy for you because the questions are numbered, so you can easily compare by noting down that question 1 true or false, 2 true or false, 3 true or false, and so on. Okay, so let us start with the questions. Homogeneous system must be a pure substance. So you have to understand what a homogeneous system is. And related question, a system containing only one substance must be homogeneous. So think about the problem. You can give pause after every slide, or you can give pause as and when you need, maybe after the first session is over, then so it's up to you. Cp and Cpm, that means specific heat and heat capacity, have the same unit, joules per Kelvin. Molar mass is intensive and has the SI unit of grams per mole. It has 2 parts. Unless both the parts are true, you cannot say it true. That please keep it in mind. Delta H is a state function. It may seem quite obvious to you, but okay, let us see the but. Okay, the first law statement, it looks like U equals to Q plus W. So again, it may seem very trivial to you, but again, let us see. The PV work in a mechanically reversible process in a closed system always equals minus P delta V. Well, the very related question, the infinitesimal PV work in a mechanically reversible process in a closed system always minus PdV. So it seems that it starts from basic definition of PV work, right? Only difference is that in the second question it is infinitesimal PV work, and the first question it is implied that it is the finite amount of work. That means in the second question it is the differential form or definition, and in the first question, this is question number 7, it is integrated. That's all. So you have to ponder on the questions and answer. There is no such thing as the change in heat of a system. Say change in pressure, change in temperature, change in internal energy, enthalpy, etc. So change in heat of a system. There is no such thing. That is the demand of the question. If delta U equals to 0 for a reversible phase, not if, delta U equals to 0 for a reversible phase change at constant temperature and pressure. Next question, the energy is conserved in every process for a system enclosed by adiabatic walls. So implies that there is no exchange of heat energy between the system and surrounding. In that case, the energy is conserved, okay, of the system. Related question: if neither heat nor matter can enter or leave a system, the system must be isolated. So this question brings you back to the very first class of your thermodynamics. Maybe you remember that where the teacher explained about the system and their types, etc. So it looks like a definition of isolated system: neither matter nor energy. So okay, let us see how do you answer. Enthalpy is often called, though misleading, heat content as delta H is equals to Q at constant pressure. So why it's misleading, that also you have to answer. And very related, delta H is QP, constant pressure, that it may mean that the initial and final pressures are the same, and only under that condition delta H is equal to QP. Is it the only condition or what? Okay, so let us explore later on. Cp is a state function and it's an extensive property. So it has two parts. You have to check both the parts, right? The state function H must remain constant in Joule experiment. So I just give a clue that there are two such experiments very similar, Joule and Joule-Thomson. Every process that has delta T equals to 0 is an isothermal process. So that starts with the definition of isothermal process. And mu j, the Joule coefficient, is neither extensive nor intensive. So it looks a bit awkward question that as we know that the property is either extensive or intensive, but can it be so that it's neither nor? So let us see. Actually, for this interesting question, I have prepared a different slide which I will not explain, of course, but if you are interested, you can go through the slide giving proper time of pause. And please, I request you to go through this slide carefully, because it gives you a very peculiar, interesting example, mu j, which is not extensive or intensive. So how it follows? It is given in a clear tree structure. The basic thing is that often a bit misleading definition we give that a sub property which is mass dependent is extensive. So in that case, what mass itself is, right? So whether mass is mass dependent, it leads to some awkward situation like this. Actually, the answer includes that you have to ask two questions: whether the property is additive. First of all, whether it's a size dependent or not. Depending on yes and no, you can then ask whether it's additive or not. Then again yes or no, and finally you get the answer. Okay. So please ponder on this slide. Okay. The next question: to raise temperature of water from 25 degrees centigrade to 30 degrees centigrade at 1 atmosphere with Q less than 0. That means the system releases heat. Is it possible? Temperature is raised, but we are not putting heat, rather the system is releasing heat. So think about the problem. Next question: the quantities enthalpy, internal energy, PV, delta H and P delta V all have the same dimensions or units. So you have to check one by one, and then you can come to the conclusion whether the overall statement is true or false. The next question: for a constant volume process in a closed system, delta U is equal to delta H. So maybe you need some help of some equations, and then you can explain. Next question: for a fixed amount of perfect gas, PdV is nR dt for every infinitesimal process. So this 21 and 22, these two questions are very close. We'll see in the explanation part. For a fixed amount of perfect gas, U and H each depend only on T. So again, it reminds you of some important equation in thermodynamics. From that only you can give the answer. So in fact, my earlier episode, that's ConQuiz bonus, I have put some light on all these things. So, and the link for that earlier video is given in the description below. So if you are interested, and I request, because it is very interesting really, because it shows that how thermodynamics, the overall load is reduced to 50%. So you must go through that if you have not already. The next question: U remains constant in every isothermal process in a closed system. next question, delta T must be 0 for an adiabatic process as Q equals to 0. So we know since our childhood that heat and temperature they are interrelated. So for increasing temperature, a Q is important, but is it the sole thing? Only important thing? The related question, Q must be 0 for an isothermal process as T is constant. So this time T is constant, so Q must be 0. The earlier was Q was 0, so delta T must be 0. So they are very connected. Next question, in an adiabatic expansion of a perfect gas into vacuum, which is actually Joule's experiment, as you know, all the 4 quantities Q, W, delta U and delta H are 0. And the similar question for Joule-Thomson throttling experiment, that all 4 same quantities are equals to 0. Before you give actually or see the answer in terms of true and false, I have again prepared a different slide for this. Each of these 4 quantities is positive, 0 or negative. So I have explained, but I am not explaining right now, but I must request that you please give some time, giving pause to this part of video, or whenever required you can come back also, of course, to see that all 4 are 0 for both the experiments, but the logic is slightly different in these 2 cases, because the experiments though very close and similar, but they are not exactly the same. That is why. And a beautiful exercise is given, that the relation between Joule's coefficient and Joule-Thomson coefficient. Okay, I have taken it from Levine's textbook, and not only that, I have solved the problem. So again, I request you to give pause and just have a glance of this slide after you try on your own to find the answer. So that slide would help you to get the final solution in details. Okay, so let me go to the next and last part, Joule and Joule-Thomson. So as I mentioned that they are very close. You can, that's a part of your methodology of studying any subject, a science subject, particularly physical chemistry, that if you can put 2 different or 3 different aspects under different heading, that means on the same footing, if you can compare the different aspects. So here I have compared the cause of the experiment, the effect of the experiment, what are constants, what is the how you can define the coefficient in the same way, and in the same way we get the expressions, etc., etc. So please have a look of this slide separately, and now I would like to give you the solutions, and I hope that you have noted your answers or solutions and you are ready with your solution logic. And if you are, now you can check and compare your solutions and answers with the right ones. Okay. So quickly I am going through the solutions. First one, homogeneous system must be a pure. No, you can think of a mixture which is also homogeneous, right? So it's a false statement. System containing only one substance must be homogeneous. No, again it's false, because you can think of 3 different phases, ice, water and vapor in equilibrium, of course at a particular temperature and pressure. Of course it is not a homogeneous system, but the substance is the same, water, right? So it's false. Cp and Cpm, well, one is joules per Kelvin, another is joule per Kelvin per mole, right? So they are not exactly the same. Molar mass is intensive. Yes, any molar quantity of an extensive property is a ratio of extensive by extensive number of moles, right? So it is an intensive property. But if you are not careful enough, then you will probably miss the point, second part of the question, that SI unit is given in grams per mole, and it is actually kg per mole, right? So it's a tricky part of the question, and the question is false. Delta H is a state function? No, H is a state function, right? U equals to Q plus W, as it seems the first law. No, really not. It is delta U equal to Q plus W, right? So these are the tricky parts. The PV work in a mechanically reversible process, and the same similar questions. So the next question is true, because that is the definition of PV work minus PdV. But if you integrate to get P delta V from PdV, you have to assume that P is taken as constant. Then only is P delta V. Otherwise, say for isothermal expansion or compression, P to be replaced by RT by V for ideal gas, and then you get RT log V2 by V1 is the expression for work, right? So it is not simply P delta V. So in general, the statement is false. There is no such thing as the change in heat of a system. Yes, of course, and the same is applied for work, because heat and work, as you know, are not state functions. So pressure, temperature, enthalpy, they are state functions. So you can say that change of that U or H or P or T of a state of a system, but heat, because it's not a state function, so how you can say that heat of a state or change of a system from one state to the other? You cannot, right? But as best you can say that heat of a process in transit, or work involved in a process, not work of a state. Okay. Delta U equals to 0 for a reversal phase change at constant temperature and pressure. No, you know, it is actually delta G, not delta U. Of course, delta U can be 0, but that is under different condition, not at constant temperature and pressure. The energy is conserved in every process for a system enclosed by adiabatic walls. So you may think that, okay, adiabatic walls, so there is no exchange of heat energy, so energy is conserved because no exchange is there. But internal energy of a system can be changed either by means of putting on some heat or releasing some heat, and as well by doing some work, right, or getting some work from the system. So only adiabatic wall and exchange of heat is restricted, that is not enough for keeping energy to be conserved, right? So it's a false statement. And if neither heat nor matter can enter or leave of a system, that system must be isolated. It looks like that exactly match with the definition of isolated system, but be careful in that definition, as some textbooks miss actually, that it should be read like there is no exchange of matter or energy in any form, including heat and work. So here work is not mentioned. So that means by means of work you can change the internal energy. So it is not an isolated system. So that's a false statement. Okay. Enthalpy is often called heat content. Yes, because change of enthalpy is sometimes after constant pressure condition is equal to Q. So Q is delta H is heat content, change of heat content. It is true, but why misleading? Because it may give you a sense that because QP is equal to some change of some state function, so Q itself is a state function, but that is not true. So that's why it's misleading, if not wrong. The next question, delta H is QP, constant pressure. So constant pressure, immediately it may seem that it implies that initial and final pressures are same. So is it that only under that condition delta H is equal to QP? Okay, to answer the question, let us think of a cyclic process, right? So cyclic process, you note carefully that because it's a cyclic process, so initial and final pressure are same because P is a state function, and delta H is 0 because H is again a state function. So delta H is 0, but if it is equal to QP, then QP must be 0, but you cannot be sure because QP is not a state function. So even in a cyclic process, QP may be 0, may not be 0, but delta H must be 0. So it is not necessarily true, right? So it's a false question. Of course, if you keep P constant throughout, then it is apart, no problem. Cp is a state function and its extensive properties. It's obvious because it's a ratio of extensive and intensive. So it is itself extensive and a state function, of course. State function H must remain constant in Joule experiment. No, actually it is U in joules, but H in Joule Thomson experiment. Okay. So that you in that slide you can check carefully. Every process that has delta T equals to 0 is an isothermal process. No, delta T equals to 0 means T initial is T final, but isothermal means throughout temperature is constant. So that is false statement. Next question that I have already discussed, that Joule coefficient is neither extensive nor intensive. So go back to that slide if you want, giving pause at this moment to see and detailed answer to this question, but that is very interesting. Next question, to raise temperature by releasing some heat from the system. Is it possible? Usually put some heat to raise the temperature, but as I already told you that for increasing or decreasing temperature, Q is not the only sole factor. Work can also play its role. So we can vigorously stir the system of water, and we can raise the temperature even if we can arrange that the system itself releasing some heat. Okay. So you can check, of course, that it is all the same dimensionally, and it is the energy dimension. You can check it. Okay. For a constant volume process in a closed system, delta U is delta H. Well, if you start from the definition of H is U plus PV, and you take the differential and dH or then integrate, then you should get delta U plus P delta V plus B delta P. Only V constant is not enough. If you have to put P constant also, then only these last two terms would be 0. So delta H would be equal to delta U. Okay. For a fixed amount of perfect gas, PdV is nRT. Again, the same type of reasoning. PV is nRT. So if you take the differential PdV plus VdP on your left, and on your right nRdt. So again, unless P is constant, you cannot write PdV is nRdt. Okay. So same reasoning as the earlier question. For a fixed amount of perfect gas, U and H each depend only on temperature. Yeah, it's true because it is perfect gas mentioned, but in general it's not true actually. And where from we answer these questions, you don't have to memorize this, but this thermodynamic equation of state, very important equations pair, del U del V and del H del P at constant temperature, they are equals to 0 for a perfect gas. So H and U, if temperature is constant, then their variation with pressure or volume is 0 for perfect gas. So the statement is true. U remains constant in every isothermal process in a closed system. Again, it is valid for perfect gas from the earlier questions reasoning. The del U del Vt is 0. So isothermal, so temperature is constant, but it is valid for only perfect gas, not in general. Delta T must be 0 for an adiabatic process as Q equals to 0. So as I have already mentioned that Q is not the only and sole factor for change in temperature. Work can play its role, change in internal energy can play its role. So you cannot say necessarily true, so it's a false statement, and very close that again it's going to be a false statement, right? And the last two questions, Joule and Joule Thomson, all four quantities are 0, that I have already explained that in both the cases the answer is true, but however the reasoning is slightly different. So you please go back to that slide if you are interested, and I think you should be interested. So to check the reasoning behind these two answers. So thank you very much for watching. Our next video is will be coming soon, and that depends on your necessity and demand. Please make comments in the YouTube video. So what you want, and is it okay with you the way I am going? And the next session, that means ConQuiz-10 will be coming soon, and that too would be on thermodynamics, your most favorite subject, and that is part 2 of thermodynamics series. And rapid fire on question answer on true and false type question answer will follow, but this time on the second law. So till then, please keep on watching, do subscribe, encourage your friends to subscribe, and enjoy learning. Okay, so thank you very much once again.